Using this triangle, we're going to try to prove the cosine law. So as you can see, we have ABC. Across B is this length B, and we have X being this small length here. Let's begin by using cos, focusing on the left triangle. Cosine of C is adjacent over hypotenuse, so it's x over a. Multiplying both sides by the denominator, we get x equals a cosine of C. So we use the cosine trig ratio. Now let's use sine. Sine of C is opposite over hypotenuse, which is h over a. Let's multiply both sides by the denominator. So now we have h. Now let's use the Pythagorean theorem on this right triangle here. We have c squared is equals to h squared plus this length here squared. And this length here happens to be b minus x. So we're going to substitute h into here. So we have c squared is equals to h squared, which becomes a squared sine squared c. Sine squared c means sine c all squared. And we're going to FOIL this out. Plus b squared minus 2bx plus x squared. And let's substitute x with this expression here. So this becomes, so we're going to replace x squared with a cosine of c. C squared equals a squared sine squared c plus b squared minus 2bx, which happens to be a cosine of c, plus x squared. When you square this out, this becomes a squared cosine squared c. Cosine squared c means cosine c all squared. So we're going to move this term over here. C squared equals a squared sine squared c plus a squared cosine squared c plus b squared minus, we're just going to copy this part here, but we're going to switch a and b, minus 2ab cosine of c. Now we're going to factor out a squared. C squared equals a squared sine squared c plus cosine squared c plus b squared minus 2ab cosine of c. And next year we'll practice some more trig identities. We'll learn that sine squared of an angle plus cosine squared of an angle equals 1. So essentially a squared times 1 just cancels out, and we have the cosine law formula. This formula, c squared minus a squared plus b squared minus 2ab cosine c, is nice to memorize.